In this video, I'm going to give you an explanation of why the circle theorem, where the angle at the centre is twice the angle at the circumference. Sometimes this is described as an arrowhead, but it's better to be able to get the description correct. So the angle at the centre here is twice the angle at the circumference. And I'm going to do this by using isosceles triangles and other simple facts that we know about circles and triangles. I've added a line here that splits the triangle into two separate parts. I'm going to use that to show why the angle at the centre here is twice the angle at the circumference. So here, this line here is a radius of a circle. It goes from the centre to the outside of the circle, and the orange line from the centre to the outside is also a radius. So we know that these two lines must be equal. So what I've got here is an isosceles triangle. Also over here I've got the radius again, and I've got another radius here. So these two lines must also be equal. So now I know I've got a separate isosceles triangle here. Now I'm going to call this angle at the top here x, and the sides of this one must be the same because it's base angles of an isosceles triangle, so I'm going to call that x. At the top here I'm going to call this angle size y, and this other base one here y. So they're both y. So now let's see how this helps us. So the sum of the angles at the circumference, the two angles up here must be, these two here, must be equal to x plus y. Now let's look at the size of this angle here. Well, in this triangle here, two base angles add up to 2x. So the angle at the top here must be 180 take away 2x, which means the angle on the outside, this part here, must simply be 2x, because these angles form a straight line. Similarly, in this triangle, the angle here at the centre must be 180 take away 2y. So the angle on the remaining part of the straight line here, this part here, must be 2y, because these two must add up to 180. So the two angles here at the centre, if you add them together, will be 2x plus 2y. Or written another way, we factorise it, we can say that's the same as 2 lots of x plus y. So if this angle at the centre is 2 lots of x plus y, it must be twice the angle at the circumference, because that's just simply x plus y. So it's a very simple explanation involving radiuses of circles and facts around isosceles triangles.